Yeah, so ownership is an interesting, memory ownership is an interesting thing. I think up until Rust, people, it seemed like in the software world, had almost decided on the attitude of GC1, get over it. If you're still pre-GC, like get with the times, are you still writing assembly too? But then Rust was like, actually, y'all, this can be, and the reason for that was, with the kind of C and C++, it's just very hard to get ownership correct and not have leaks or use as after freeze. And Rust showed like how to make that safe. And you have to do more work statically, but it's possible. And then the gains that you see for when you do when you have explicit ownership, you just don't have these GC pauses, and it's become, I think, kind of a somewhat periodically there'll be a post on Hacker News saying how we took our, got our whatever 99th percentile latency down by switching to Rust, and it was easy, and we didn't have to spend any time. And before, we were pulling our hair out trying to find where's the leaks coming from, how are these things surviving the generation, the survive getting promoted into the tenured heap, and all that hard stuff. So Rust has made it popular, but it's at the cost of, the ownership system is hard. It's kind of complicated. You have to learn deal with some serious types. Is there a really simple alternative? Not that I'm aware of. I've heard in C++, I saw there was some efforts to try to kind of overlay a type system on top of C++ to kind of emulate some of those things you can get from Rust. But there's the safe Rust route, and then there's the kind of very simple but error-prone C route of just don't forget, just try your best. Good luck. But I'm not aware of something, and I mean, now trying to enumerate, there's also the Objective-C routes, which is automatic reference counting, and then there's this explicit way to have things survive. And I'm not intimately familiar with that system, but actually from time to time I hear good things about it. I keep intending to learn like intimately what that system is. I don't think automatic reference counting handles cycles. I think it's on you not to make a cycle in those languages because they don't have a cycle collector, which might be fine. Yeah.
Yeah, interesting. Just a note on cycle collection. That's one of the things that Firefox has that's quite powerful. Is that the cycle collection is relatively efficient because you only have to cycle collect on objects that have changed their reference count. But you can sort of look at cycle collected reference counting as kind of a different kind of GC, right? Yeah, I don't know. It's like the ideal thing in any programming language is to express your intent most directly, and it's ideal from that point of view not to have to worry about memory. The problem with memory is that it's not an inexhaustible resource, and how much memory you use actually does matter. And so I've experienced programming in Java and for quite some time, and one of the problems you get is you end up using memory and not knowing about it. And I think one of the things that I would say about Rust that makes it good for high performance applications is that you can't use memory without knowing about it, and for the most part, you're not using CPU cycles without knowing about it. The problem with that is that you have to deal with it if you know about it. And so it's kind of you got to think about the domain, the problem domain you're working in, whether it is worth it to know about memory allocation. Is it worth it to know about every CPU cycle? And sometimes it's not, and sometimes it is. It depends entirely on the domain. And I would say that's kind of one of the successes of JavaScript is the fact that the barrier of entry is really low because you don't need to deal with anything at the beginning. You can just deal with everything later. And that's really what made it successful. It's like, yeah, deal with everything later. Rust is the opposite. It's like, yeah, you got to learn this shit.
And looking back at the question, I saw that the important final part of the question was in Wasm. And so initially my answer would just been like, no, that's a higher level. That's like the programming language. Wasm doesn't have any opinions. Like, here's a bunch of bytes. You can ask for more. And so mostly that's a programming language concern. However, I think going forward, as we start to like develop this pure WASM ecosystem, you start to say, well, what happens when I have multiple WASM instances and they're dynamically being created? Can I also destroy them? Because if I could, it would be a very clean way, just like when a process exits, it takes all its memory with it. And so here you hear about Unix style GC, which is just don't ever free, the process will die, the memory will get freed. Like that's actually kind of a beautiful model if you have really short running computations. So I actually have some sort of hope that as the pure WASM ecosystem emerges, we can build up the tools and the things like interface types and module linking and some other stuff for being able to spawn really small short-lived WASM instances that allocate some memory, don't even care about freeing it, and then just die and take it all, the instance gets freed and the memory goes away. So that I actually have some hope for the future, but it's farther out.
Yeah, I'd like to mention actually that there is some like life cycle things, opportunities in WASM that haven't been thought out, right? The life cycle of one module does not have to be for eternity. It can be, I think there's a lot of opportunity there to be able to say, well, we're running this thing for a while, and then the memory and the code are separate, or have separate life cycles. I think there's a lot. Like, I think one of the things I'm really excited about in WASM is that there's so much opportunity that's undiscovered. We will continue, as Luke was talking about earlier on in the session. We're going to continue to discover new things as we try and solve new problems, and as we discover new things, more opportunities turn up to be able to do things that weren't in the original plan.